Hi, and welcome back. So, on the next video, we are solving the example 2.11, and as I said on this video, we will solve the example 2.12. We are still talking about uh, transformations relative to a rotative referential, and we saw that on the last video that we can do transformations on a fixed reference system and on a rotative reference system. And the example 2.11 was about this. On this example, we do transformations on both reference systems. And now let's solve the example 2.12. So the example 2.12, it says that a referential f, it was rotated 90 degrees in relation to the axis y, followed by a rotation of 30 degrees in relation to the axis O. And again, notice that we are doing transformations both on the reference system fxyz and on the reference system fNOA. Then it was made a translation, then translated 5 units throughout the axis N. And finally, it was then a translation, another translation, and finally a translation of 5 units throughout the axis X. And it asks for us to find the total transformation matrix. T. So we have a rotation of 90 degrees in relation to the axis y. So is a rotation of 90 degrees above or around the axis y, followed by a rotation of 30 degrees in relation to the axis O. So it's a rotation of 30 degrees in relation to the axis O. Then a translation. It was translated 5 units throughout the axis N. So we have a translation of 5 units throughout the axis N. And finally, a translation of 5 units throughout the axis X. Four units. I said 5, it's 4 units. 4 units throughout the axis X. So the total transformation is equal. These transformations write on the right order to represent these transformations in relation to the reference system or in relation to the referential, the actual referential, the current referential. So is a translation of 5 units, a rotation of 9 degrees, a rotation of 30 degrees, and a translation of 5 units. And writing this equation on the matrix form, the first is the translation. So remember, when we are doing a transformation of translation, we have this identity matrix, which is characteristic of a transformation of translation. And we add the scale factor W. N is a translation of 5 units throughout the axis N. So is NOA. And a rotation above or around the axis Y. So let's see the characteristic matrix of a rotation above the axis Y. and is of 90 degrees. So if we substitute these terms of the matrix, so cosine of 90 is 0, and sine of 90 is 1, so it's minus 1, 1, 0, and we have to add the scale factor to keep this matrix on the quadratic form. Now a rotation above the axis O, but now of 30 degrees. And right now we need to know the direction of this unit vector. So we just when we are dealing with these situations, we just need to write the reference system. So let's just remember the direction of this unit vector of this axis. Is A and O. So O is on the same direction as the axis Y. So we can use this characteristic matrix. But now is cosine of 30 degrees, which is equal 0.866, and sine of 30 degrees, which is 0.5. Right here is the same. And adding the scale factor, okay. And for the last, we have a translation transformation of 5 units throughout translation transformation of 5 units throughout the axis and so it's the same as this one, but you are saying that is this transformation of translation of 4 units. It was throughout the axis x, but now you're doing this transformation of translation throughout 5 units throughout the axis n, which is on the same direction as the axis x. So if we're going to have a quite similar matrix. It just need to change right here for 5 units. And doing this multiplication, we obtain the following matrix, and that's it. So on the next video we will start the topic 2.7, which is about inverse of transformation matrices. And that's all for now. Hope you like. So see you on the next video. Bye bye.